And beverages. It should be water only. Good example is directly. So food and water only. Okay, now I'm talking, I should be here. Focus, focus, look this direction. Thank you. Awesome. Second reminder is when the bell rings, we get to our seats. If I'm late, I'm late. If you're late, you're tardy, you have to go to tardy slip. So,
Like her.
you better be in the class before the bell rings. And I realize that sometimes I might be late. If I'm walking down the hall and the bell rings and I see that you're not in the class and the bell rings, you're tardy. So make sure you're getting here on time. If you lucked out that you were tardy and I wasn't coming down that hall to see that, you got lucky one day. But we're making that too much of a habit from some of you guys is that you're walking in late every day and you need to be here on time.
I have an excuse. My class is really far.
You're going to have to hustle your butt to get here.
Okay, I was trying to come in and someone blocked the door.
If someone's blocking the door, then I'm going to write that person up for blocking the door.
We should make them go get a pass.
So, you're blocking the doors, people.
Shorty.
Next item. Shh. Tomorrow, I will not be here.
Yay.
The chem teachers are gone for a meeting at the district office. So, there will be some.
What about math teachers?
Not to my knowledge. I know the chemistry department has a meeting with math does. So, what am I going to ask for you guys then? Shh. Please get here on time and get your assigned seat to make it easy for the subs. So they can easily mark tens. I don't know who it's going to be. So, tomorrow. Okay, because they might not know you by face. They might not know who you are. And they might just see your seat is empty. I'm going to mark you absent. Because they don't know any better. So make sure that you're in your assigned seat. After they take attendance and they give you the instructions for what you're going to do during the class period, if you want to get together and work quietly with some other people, you can. As long as you're doing that, you're working quietly with other people. You're not being disruptive. My plans are today we're going to finish up a certain section of our notes. We're not going to get any farther than number 28. So we're going to finish 27 and 28 today. That's our goal. That's not a lot of notes, right?
Why can't we just finish the whole thing? We've been on this for like 2 days now.
I understand that.
So,
I'm just saying.
I understand that.
So you mad?
Because we have a couple of different assessments. Shh, let me respond to that. Shh. Okay, part of the reason we're taking so long is because we're talking too much to get anything done.
Don't, please don't. I hate you.
There's some of us that are trying to learn in here.
So stop talking.
so we gotta use some alcohol.
Hold on a moment here. Let me finish my talk, please. Then we can get some stuff. I know. Hold on a moment. We're going to do a couple of assessments based on the information we talk about. We have a small quiz coming up this week on the phases of matter and on physical and chemical properties and physical and chemical changes. Before we get to that small little quiz, which is probably a formative assessment, we also are going to be doing a lab later this week. We also plan to be doing a couple of other small assignments that kind of relate to this idea of solids, liquids, and gases and how they all relate to one another. So for us to go farther ahead here into the part on elements and mixtures and compounds, we're not ready for that yet. I want us to kind of take stock of what we've been working with in terms of elements, or in terms of solids, liquids, and gases before we move on. So that's why we're kind of doing it a little slower, which is okay. If you want to pass your comments to me, all right, so we've got our solids information up that we started with on Friday. So to fill the rest of it, if you haven't kind of noticed how things work.
Miss, I wasn't here on Friday, so I didn't get.
You weren't?
I wasn't here on Friday.
Yes, you was. Both of
If you were gone Friday, if you were gone Friday, and we're done getting the notes from today, you can see someone or see me to get the notes that you missed from Friday. Okay?
All right, yeah.
Can I get it? Can I hit you? Yeah.
So,
Give it here. You come. You want to hit me? You want to hit me? You want to come here and go to the room. No, I think that's just like, I want to set this here. No. Oh, my hand itching. Oh, yeah. Nice.
It went. It's just taking a little while.
Miss, patience.
okay, so, liquids.
Me and Peanuts got the win.
So we're on 27 and 28.
we're on 27 and 28. Hold on.
Yeah, you can.
Whoa,
Are you
Brandon.
taking this one?
I can tell you that I use it.
Are you using notes?
What do you got? You got? Can I get one?
I have no idea who it is, but anyway. You're going to have them sign this that you did not use any notes.
I know you wrong with
What's up?
Oh my God, you're gonna knock you out. Your phone is dead.
Your pencil by St. Paul.
Huh?
All right, ladies and gentlemen, on Friday we talked a little bit about solid particles and tried to mention how with solid particles, their shape is fixed. It stays the same. Right? We call that a definite or fixed shape. And we said the volume also is the same way. It stays the same amount of space that it takes up. Doesn't change. Now the particles are very close together in a solid, as we kind of see in the picture. They move very slowly. They just kind of wiggle in their own little spot. They can't get out of their spot. So today we're going to look at liquids. And if you fill in the first column there for liquids, they have a indefinite or variable shape, right? We know they take on the shape of the container that they're in. So we're going to get a little bit of water. Put some water in here.
Hey, can I be a little more?
Keep our class under control.
Look at Snoopy.
Okay.
What are you
So
doing?
if I take water, we know it takes on whatever container shape we put the water
No.
into, right?
I don't
So
care,
we'll put some water into
nigga.
this syringe up here.
Hey, what happened to that other lady that was in here?
You ain't making no video.
Miss Kendall?
Miss Kendall, she is, I think.
She's in Orlando, Florida.
Right, she's on a.
And she didn't take me. What a bitch.
Have them up there?
No, Mari, stay right here by me.
No. Have them up there.
Did that hurt?
You can if you want to. If you recognize.
Can I come over there?
Well, I'm
Damn, look at
gonna
that.
put this here for a moment. Shh. Now, even though the liquid takes on the shape of the container that it's in, so I put some liquid inside the syringe. Shh. Notice that we set up here that maybe we did say. You want to click? Oh, sure.
Mari, turn around.
That the volume is definite and fixed. The amount of space the liquid takes up always stays the same. So the amount of space that the liquid is taking up inside the syringe here, if I try to squeeze and put the liquid into a smaller space, I can't, right? It's stuck in there.
It's that.
Just like if you have, how many fluid ounces here? 20 fluid ounces of liquid. Can I pour this into a cup that's an 8-ounce cup and get it all to fit? If it's 20 ounces,
Got that on tape.
right? Ounce is the way that we can measure the volume in here. I can't pour this into a smaller container and expect it all to fit in there. Can I fit that all in here? No. Right? It takes up a certain amount of space, and that doesn't change. It's a fixed or definite volume. Should I let go?
No, yeah, squirt her. Squirt her with it.
Yes. Good.
Squirt her. Make her, never mind.
It was a hot day. I'd get you. It's not a hot day. It's winter.
She trying to get wet.
It's so
Mari,
Arizona.
trying to get wet.
This is not a wet t-shirt contest. Well, what's that?
All right, now the
Do whatever you like.
kinetic energy of the particles. Kinetic energy of our particles. If you look at the particles in a liquid and a solid, right? Solid, we said they're kind of stuck in their place, and they just kind of wiggle and vibrate.
Hey, she got her
a little bit in
hair
place.
done. Hey,
I can't see back
You.
here. I need glasses.
You can come on up closer.
you ugly.
If we need to see change, we can.
I swear to God.
Come
He
back.
swear to God.
What do you swear to God? You should be saying.
He swear on Jesus.
Hey, Stu.
I gotta say next day, Eric.
I'm sorry, but he made me laugh. I'm sorry.
See, I'm not a part of that this time.
Shut yo. Wait till you come back over.
So, back to our particles. In a solid, they're just kind of stuck in their own place, and they just kind of wiggle a little bit and vibrate in their place, right? They can't get out of their place. So they have very low kinetic energy. They don't move around a whole lot. In liquids, the particles are still pretty close together, right? And the fact that they're close together, that's why we got that definite volume, right? There's no way we can squish them closer together. They're already close together. And they're gonna have connections and bonds that don't allow them to just spread out. So they're still stuck in that definite volume. They take up a certain amount of space because they're really close to each other. But this one says that the particles can kind of move around even though they're close together. So unlike the solids that kind of just wiggle in their own little spot, these guys can move out of their spots. They kind of slip and slide past each other, but they can't separate apart from each other. Okay? They're kind of connected. They have like a Find our pen. Ball pen, I guess. All right, in a solid, particles are connected to each other, bonded to each other. They're stuck. If I'm stuck to somebody else, I can't just spread away from that person, right? I'm stuck with them. And in that solid, they just kind of wiggle next to that partner, and that's it. A little bit of energy, a little bit of movement, not a whole lot. The liquids are still connected.
You hear me?
What did I miss?
They're still connected, so they can't spread apart from each other. They're still connected to each other. But this time the connections are a little looser. Maisie? And they can
they get
break
looser.
that bond sometimes and slip over to the other side, and then they can reform that bond on the other side. So they don't have to stay in the same spots. They can kind of move out of their positions and slip and slide past each other. So we have a little bit more movement, which means a little bit more energy, right? So we went from very low kinetic energy, very little movement, to a bit more movement. Not a lot, still a pretty low amount of kinetic energy. And they can move out of position, but they can't move away from each other. Okay? Have you guys filled in the column for liquid?
No.
I don't even have that.
If you haven't, you should be doing that
Yeah, you
right
should be
now,
doing
right?
it.
If you look in the box, remember shape, you have the two choices there. For liquid, we're going to say the indefinite or variable shape. For volume, you have your two choices. We're going to fill in the one that says definite or fixed. For the kinetic energy, we're going to fill in for liquids. Oh,